So consider a uniform electric field of value, how much? 3 into 10 power 3 I cap Newton per Coulomb. What is the flux of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane? So how to solve this? So what is the flux of this field through a square? So there is a square of 10 centimeter on a side whose plane is parallel to YZ plane. Meaning? Okay. See, this is x axis, y axis, z axis. Whose plane is parallel to YZ plane means it is something like this. Okay. This is y, this is z. So this is the YZ plane, and this is how the electric field is. So whenever a plane is parallel to YZ plane, right, what will be the direction of its aerial vector? See, it's very simple. X axis, y axis, z axis. So if they say YZ plane, right, if any shape is confined to that particular plane, its aerial vector will be in this direction. Similarly, if I say something is confined to xy plane, then its aerial vector will be in the z direction. That's it. It's very simple, right? So in this case, aerial vector is going to be equal to 10 into 10 power minus 2 the whole square, because a square times I cap, right? It's going to be in terms of meter square. So what is going to be the answer? 10 into 10 power minus 2 is 10 power minus 1. 10 power minus 1 the whole square is going to be 10 power minus 2 times I cap meter square. So what is going to be the flux? It is going to be E vector dot A vector, multiply both. So 3 into 10 power 3 into 10 power minus 2 I cap dot I cap is going to give you a 1. Answer will be 3 into 10 power 1, which is going to be 30 Newton meter square per Coulomb. Am I clear with this? What is the flux through the same square? You have the same square, right? But in this scenario, what is happening? If the normal to it, right, normal to its plane makes an angle of 60 degrees with the x-axis. So if this is going to be the x-axis, if this is going to be the normal, for instance, right, how is this normal? It is making 60 degrees with the x-axis, right? So this is going to be 60. Then how do you calculate the flux? Why 90 minus 60? See, this is the electric field, okay, and this is how the normal is. Normal makes, what is the same square? If the normal to its plane makes an angle of 60 degree, okay, tell me, huh? Why? Okay. See, how is the normal taken? So this is the direction of electric field, no doubt in that. It is fixed, positive x direction, right? Now how is the square? So are you taking it like this or like this? Like this. Okay, if you say this is going to be the normal for the, this is going to be the normal for the paper, and this is the x direction. How much is the angle between both? 60, right? Then why do you want to take 30, 90 minus 30? If you draw it right, the square is going to look something like this. So this is going to be the aerial vector. So what did they say? What is the flux through the same square? The same square, if the normal to its plane. So this is the plane, and the normal to the plane is like this. Normal to the plane makes an angle of 60 degrees with the x-axis, right? This is going to be the electric field. Now what is going to be the angle between both? 60 only, no? Why do you need to take 30? Had they told the plane is making an angle 60, then you should take 90 minus 60. Did you solve this problem already? Similar to this, because yeah, I'm just checking, there is another problem. Because as per the question, right, I'm just checking, is it the same thing? Am I understanding it wrong? Is this the same thing given in textbook? Can you check it once? The normal towards plane. So this is the plane. Normal towards plane is this thing only. Normal to the plane makes an angle of, correct only, makes an angle of 60 degree with the x-axis. Electric field is already aligned to x-axis only. So it should be cos, answer should be 15 only. What is the answer given at the back? Check it once. Because I was trying to see, there are two things. What you say, 90 minus will come. I'll tell you in what scenario it will come. In this problem, it will not come. I hope everybody is able to visualize what I'm trying to say. Right? Try to understand this language. This is where we'll get confused. The square is there. There are two normals we define. One is normal to the plane. One is the plane itself acting like a normal. Okay, so you need to be very careful. In this question, what they are saying is the square is there and the normal to, so initially it was like this. In case number A, it was like this. That is why what happened, we took I cap. Right, we should not forget that electric field is confined to x direction only. When they say normal to the plane is making 60 degree, I can either take it like this or like this. Both are same. I could have tilted it like this and kept. I could have told that this is the normal. Then also the angle would have been 60 only. But sometimes what will happen is they will say the square is perpendicular to it, or the plane of the square is making an angle 60 degree. So if this is how electric field is. If the plane of the square is making 60 degree now, it will rotate like this. Then the normal will not be 60, rather how much will it be? So it will change accordingly. So that is where we need to be careful, where to take that 90 minus and where not to take. In this problem, we need not take. Right? So how much is this going to be? 60 A. So EA cos 60. E is how much? 3 into 10 power 3 into A is 10 power minus 2 into cos 60 is half. So basically it should be half of this value. Actually, it's a simple problem only.